Okay, now let me go on and let's start looking at the questions that has been posted and let me start answering them. Okay, so Robert Sanich Chung is asking, thank you for organizing the presentation. Will the slides be shared? Yes, slides will be shared. And for all the attendees who are registered, they're going to get a JVM performance ebook. It will be sent to you in the email. And also this deck will be published in the blog.ycrash.io. Okay, so now the next question from Ganesh Padmanabhan. How AI agents, LLMs, RAG are going to evolve in the JVM tuning space? Can this really help apart from anomaly detections with ML algorithms? So Ganesh, this is a very profound and a very deep question. I don't know whether I'll have an opportunity to answer in entirety, but let me give you a pointer. I think I already put it in the chat. See, look at this. This space is very, very exciting, right? I'm thinking we are going to see AI assistants helping us to troubleshoot the problems, right? See, the way I'm thinking, even in Ycrash, we have a lot of APIs available which can analyze all these artifacts. So these are all the artifacts that you need. We have APIs available to capture these dumps. And we also have APIs available to analyze these dumps. And we can present you all the information in a JSON response format. Say today, if you're going to trigger a thread dump analysis API, it's going to report, oh, these are all the problems. Oh, okay, this thread acquired the lock and did not release due to the threads are blocked. It gives you these kind of information. So these information can act as an input to your vector database, right? And then it can act as a very good RAG, retrieval augment, this one generation, right? Because these are very context specific thing for this incident. So what we can do, the LLMs, we already have like LLMs like ChatGPT, OpenAI, Llama. On top of it, we can train them on domain specific data, which we have curated and we have a lot of data. And then on top of it, then incident specific details can act as an RAG input. So now that means let's say the assistant can become very clever. So now as an SRE engineer, he can ask, what is my Java? Why is my application experiencing poor response time? Now the AI assistant, or because it's trained on the domain specific data, plus it is having this RAG context which is giving from the incident API response, it can answer you like this. Your Java application has 200 blocked threads waiting for this and see what to do. It can have this kind of a meaningful conversation. This is getting very exciting. In fact, one of our customers is pursuing this, building this bot for their facilitating their SR engineering team, right? Okay. Okay, so now the next question, Jonas is asking, customer doesn't pay for performance test. Okay, he says, true, maybe also the customer does not pay for performance testing. Yeah, that frowning face. Yeah, good quality needs investment, right? Okay. Okay. So Elisa is asking whether we'll share the presentation. Yes, we will share. Robert is asking, will your tool suggest JVM parameters tuning? Yes, Robert, our tool does support the parameters. Say, for example, based on your input, right? Let me see whether I can find something here. Yes, look at this. Oh, it tells, okay, you're having an evacuation pause. How do you can accommodate it? Because you need to eliminate a lot of parameters what you have configured. You have over configured. Not increase the heap size, increase the concurrent this size. So we give these kind of a pointed recommendation. So we increase this heap region size by 50%. We give you this kind of pointed recommendations, which will improve your JVM performance. Okay. So now I'm going back. Elisa, will you show some example tools, etc.? Yes, we were showing some tools. Elisa is asking, I think for JVM parameter suggestions, first we must need profiling step. Yes. Are you suggestion or your suggestions apply to generation GC, including throughput? So, Robert, to learn more about ZGC, I'm going to share with you a couple of blogs, right? And also the JVM performance course that I shared. There we talk about extensively about GC tuning. But let me share with you a couple of pointers in this chat about ZGC tuning. If you want to go about GGC tuning, what do you want to do? Here is first blog, and this is the second blog. So if you see in this tuning, where do you want to use it? And what are the parameters that you want to be tweaking? Like we are just giving a curated parameters. That's it, 6 parameters. That's all you want to use. And then in case if you want to see how the GC log will look, so look what are the fields. Now you can tune it. This in the link pointers given you will help you with that. Okay, so now I'm Fabrizio Selli. What is an LTGC throughput percentage? There is a specific safety range. Fabrizio, this is a very good question. See, the GC throughput LTNS, it depends on what type of application you are building actually, right? See, when it comes to GC tuning, friends, when it comes to GC tuning, there is 3 primary KPIs. First is GC throughput, second is GC latency, and then the third is the footprint, the overhead added by the garbage collection. So they say in this 3, you can pick 2. Whether you want to pick GC throughput and latency, that means your footprint is going to be 8. Whether you want to pick throughput, and if you want to put the footprint, then the latency can go. So it depends on them. But in general, if you want to ask me, I would try to base my throughput above 98%. I try to go as much more 99 if possible. I go, or at least I should keep 99%. If you want to know what are the different KPIs and what is the right value for them, I'm going to be sharing with you a pointer. Let me share with you a pointer here. Yes, so this is what. So here is the GC KPI metrics. What are the metrics? Throughput and what is the acceptable values? How do you go about it, right? And there are case studies on how you can improve. I will put it here. I'm sharing it in the chat. Okay. Okay. So now I'm going. Okay. Alex C is asking, does object creation rate listing is in the GC log or in another report? Alex C, the object creation rate is in the GC log. If you see in the GC log, here there's object stats section. Here there's a thing called average creation rate. This is what the object creation rate is, 54 megabytes per second. Okay. Okay. Now, Alexi is asking, what is a tool for error analysis activities? Where would you suggest? So, Alexi, all the metrics can be sourced from this one single tool, which is Ycrash. You can download the enterprise edition and play with it. So here, it analyzes your errors, and then you can click on the details to see, okay, this parsing exception 76 times it has happened. This null pointer exception has happened 67 times. By the stack trace, you're going to see, you can see the click on the view all and you can see the details. All these metrics can be sourced from Ycrash. Okay. Now, Viresh Sai is asking, do we need to run Ycrash data stream all the app servers, or the Ycrash agent will collect data? So, Viresh, the YC data script is basically nothing but the Ycrash agent only. But it's not, we don't call it agent, it's too much big claim, it's just a simple script. So in your performance lab, I would recommend running it, as I told, run it in the middle of the test and at the end of the test, trigger it manually. Even it can run automatically, it doesn't fit that well for performance lab scenario. Doing continuous production monitoring, there you can use it. But in performance lab, trigger it at the middle of the test and at the end of the test. Okay. Okay. So Viresh, will running the YC data script, will it connect the heap dump as well? Viresh, answer is no. Heap dump is because in this all this 360-degree data, heap dump is the most intrusive data and it stops the JVM. So we don't capture it. So if you want to capture heap dump explicitly, you need to pass this flag -HT. Only if you pass -HT, then it's going to capture. And I wouldn't recommend capturing heap dump, especially in performance lab. We don't want to capture heap dump because we don't want to interrupt the test. We don't let it run. And only if we know, okay, there's an out of memory error, or if you want to profile the memory, that's when we will capture heap dump and we'll do it. Good question. Thank you. Elisa Arya is asking, can you share the URL of the LLM analyze, please? Alicia, I've shared it in the chat, so you should be having it. Right? If not, I'm sharing it once again now. Okay. So now the next question, Ashok Kumar. In my application, we are using Groovy and we're always getting memory issues. Which GC or parameters will help you to bypass? So Ashok, so see, memory, friends, memory just with an out of memory error, there's 9 different types of out of memory error. There are 9 types. What type of out of memory error you're getting, based on that, your solution will vary. So unless I'm going to take a deep look at it, I wouldn't be able to answer. But I would like to give you a good starting point for you, where to look at it. So let me give you a starting point on how to go about doing this memory analysis. Yes. So this is that link. Ashok, you can look at it. Types of out of memory errors. What are the different, and here is a video tutorial on that. What are different types of out of memory errors? How do you go about diagnosing them, approaching them? All of them is given in. This is a good tutorial for you to take a look at it. Okay. Okay. So then Elias is asking, between what GC algorithm is used by microservices based in containers? It depends on JVM used. Thanks. So Alicia, it's very surprising. I just recently wrote a blog. What is the right GC algorithm for your microservices? Let me see whether I can locate that blog post. No, I don't think it's posted in, but from a, but soon, very soon it will be posted. But from a very high level, let me share that the raw post. How to choose the right GC strategy for your microservices. See, friends, right now, as we are speaking in OpenJDK, there are 7 GC algorithms: serial, parallel, CMS, G1, Shenandoah, ZGC, and Epsilon. Friends, here from this, I'm eliminating 5 algorithms for microservice. If you're going for microservice, go for G1. If your heap size is less than 32 gig, start with G1. And if your heap size is very big, more than 32 gig, and you are running on Java 21 and above, note Java 21 and above is key, then try experimenting with ZGC. Only these two are best bets for microservices, right? And if it's less than 32 gig, start with G1. If it's greater than 32 gig, and if it is running on Java 21 and above, go for ZGC, because Java 21 and above, they made a lot of enhancements in ZGC. Earlier versions of ZGC is not that performant. It has a lot of issues. They addressed it and from 21 and above. So take a look at it. Okay. Okay. So let's go back to our questions. Kishore Joyce Shula says, would like to know more about AI assistant to build tool for analyzing JVM performance? Yeah, Kishore, I've dropped that link. Take a look at it. Right. Can we use ycrash and use a licensed version of ycrash without uploading? Can we use a ycrash script and use a license? Yes, Jalaj, that's a very good question. Answer is yes. The ycrash is available on-prem installation because there are several customers who uses this, like Apple, ServiceNow, Workday, Wells for a lot of enterprises uses it. They all have their on-prem installation because we are dealing with a sensitive data. This production artifacts are sensitive data. So they all have the on-prem installation. You can have our on-prem installation of ycrash running on your prem and you can do the analysis. Okay? And then Claudia says, sometimes you're allowed to collect keep dump because it will stop. Yes. So Claudia, I answered this. By default, this script, this YC script, does not capture heap dump unless we explicitly pass this HT flag. So we don't capture. So it will not add any overhead. In fact, the script doesn't add any overhead. It completes under 30 seconds. If you don't capture heap dump, it completes under 30 seconds and then it exits. So it won't add any noticeable overhead to you. Okay. Okay. So with this, I'm concluding all the questions. Okay, friends. Thank you everyone for attending this month webinar. We will connect back with you with next month with more interesting topics. Thank you everyone. Bye.